Hi, I'm Mark Johnston. Welcome to this video on gear ratios. So what I'm going to show you right now is how you can understand the relationship between two gears and how that might change speed or torque. We're going to talk about the input and we're going to talk about the output. So first of all, I want you to imagine that you're baking a cake. All right. So let's say that you're baking a cake and you have one box of cake mix. And that's going to make one cake, right? And then you have to put in, or your input has to be one egg or two eggs. It's a pointy egg. The chicken was weird. Okay, so you have one box of cake mix, but you have to input two eggs. So the ratio for this, you might want to say is 1:2. And if you were putting the cake into the eggs, then that might be correct. You might say 1:2. But in fact, kind of the way that we're actually doing it is that we're mainly concerned with the cake, with our output. What are we gonna get? What do we have to put in to get what we're gonna get out? So our input is actually going to be 2, and our output is going to be 1. Okay. Now there are some cases, maybe probably not in the case of a cake, where you might have to input something like 3 and get something like 5 out. We don't really want to do decimals, because you could reduce this to like 1 to 1 point something, right? 1.8 or something like that. But it's very difficult in real life to have like 1.8 eggs. All right, so you need to use these whole numbers for the purposes of my class anyway. And so that's just an example, but more of a real world example is this 2:1, where you have 2 eggs that you input and you get 1 cake out. So how does this relate to gear ratios? When we compare gears, we understand that they are circles, okay? And when you have a circle, there's a few things you have. You have a radius, and then you have the diameter, which is twice the radius. And then of course you have the circumference, which is the diameter times pi, right? And so let's say we have a gear right here, and the circumference, we'll just make it easy, okay? The circumference is 3, okay? So let's say you got the circumference of 3. And you have a gear here whose circumference is 5. Okay. So when we compare the circumference of one to the other, and we know that these are going to be turning, all right, that one's going to turn that way, and this one's, okay? So we have, basically, we would think we have 3 to 5. We're inputting, or 5 to 3, that's what you would think, right? You're inputting 5 and getting 3. But in fact, that's not the case. Because I don't have to put in as many of these to get one of these. Here, let me explain a little bit more, okay? So if I have 5 to 3, really what I have to do is I am just inputting 3 turns here, and I'm going to get 5 turns there. Kind of crazy, huh? So let's look at that a little differently. Here I have a gear, and these are sprocket gears. These are intended to have chain looped around. So we have sprocket gears that look like this. Let me just do this little circle here, and I'll do a bigger circle here, okay? And then we would have a chain going around those, turning them, okay? All right, so let's take a closer look at these gears. Remember I said we have a diameter and a circumference, and what I've done is I've taken a little strip of paper, and you can actually do this yourself with these little papers right here. And what you want to do is there's this little line in here to just get it most accurate. If you go on the outside of a sprocket gear like this, it's not going to quite work exactly. So what you need to do is you need to measure or just hold it up real close and cut it exactly so it's right in that area where the chain actually sets inside of. So now what I've done is I have this little circle, and when I stretch it out, now I have the circumference. Kind of crazy how long the circumference looks compared to the gear, right? So now I have this circumference of the big gear. And what I want to know is when I turn the gear one time, it's going to go in the distance that it's going to travel is that full circumference, right? One rotation, this is what this represents, is I'm going to start here and I'm going to go all the way here, and that's one rotation. Now I want to do the same thing with the little gear, all right? And the little gear is a little bit harder to do because it's harder to work with the paper, but I did go ahead and make one of those for this little gear. All right, and then I'm going to stretch it out. All right, and I have one circumference of the little gear. So I can see here that if I travel one whole rotation on this big gear, this little gear, it's going to make it travel once, twice, 3 times. So 1, 2, 3, 4 times, 5 times. So if we input 1, this is one rotation right here. Oh, that's backwards, okay? One rotation right here. Okay, I'm going to get, and I can't draw on the black one, but I'm going to get 5 here. So think about like a big dog and a little dog, right? A big dog's got long legs, a little dog's got short legs. That big dog is going to travel this whole distance right here, and it's taking bigger steps, right? Every step it's taking bigger steps. So I got like a big Great Dane taking big steps, and I got a little Chihuahua going boom, 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 making more steps just to keep up. Okay, the same is true with these little gears. And if you see, I'm going to just kind of mesh them together here. When I turn this big gear, the number of times that I turn it, that little gear has to turn a lot more just to keep up. All right, and it can't fall behind because they're stuck together. All right, so they have to keep up. They have to spin together at the same rate right here. Okay, but the input shaft to the output shaft, the input shaft is going to be traveling slower and the output shaft is going to be traveling faster. Just like this little Chihuahua's feet are going to have to move a lot faster to keep up with that big Great Dane. All right, so now there's a mathematical way we can do this because it's not really practical. Every time we want to find the gear ratio, we don't want to have to cut little strips of paper and count them out. So there's a mathematical way we can figure it out. So let's figure that out. The first thing you need to do is with a gear, you don't actually have to measure the circumference. You have a little trick with it. Every gear, every tooth on the gear, you can use that as the circumference. So in math, you can use different units to measure things, right? You can use centimeters, you could use inches. In this case, we're going to use teeth. Okay, the number of teeth on the gear. That's these little guys right here. So if you come in real quick, we're going to count the number of teeth. And I don't want to actually count all these teeth. That's a lot of teeth. So I'm going to use a little bit of math, okay? And I'm going to look here in this spot, right? And I'm going to see that this is exactly 1/4 or 1/4, right? So if I have 1, 2, 3, 4. So all I got to do is count the teeth here and then multiply by 4. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 teeth in this quarter of the gear, all right? And if I were to continue to count, I could just double check myself here and count half of the gears or half of the teeth in the gear, which should be right there. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so exactly. So I have a 40-tooth gear here. All right, so now I have a 40-tooth gear. Let me see if I can write this like that. A 40, yep, tooth gear is the input. And now I want to figure out my output, right? What my output gear is. And this was a little bit easier because I only have a few. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. There, I'll just draw this 8 upside down. There you go. So I have 40 teeth on the input and 8 teeth on the output. Now, you might be tempted to put that little colon there, but then we would actually have it backwards. Here, I'll show you. So if you put 40 over 8, all right, we can do some math, and you can actually do some mental math, right? So 2 8s is 16, and 16 and 16 is 32, and then we add one more 8 and we get 40. Okay, so that's 5. So I have 5 over 1. Okay, so then let's draw the 5 over 1. 5. Actually 5, it is 5, yeah, 5 over 1. There we go. Okay, so 5 over 1. But we want to think about it before we write that out, because when you write it out, you're going to have a number here, and then that colon, that means like this number to that number, okay? So if we think about it, if I input one turn here, one turn on the big one, I'm getting a lot more turns out of the little one, right? If I were to turn the little one time, I'm not getting 5 turns out of this one. Okay, so that tells me that my input is 1 and my output is 5. So it's 1 to 5. If I input 1 turn here, I get 5 turns out here. All right, so that is a really simple way that you can do gear ratios. Another way is you could, instead of doing like the little paper, you could just simply count. Once you have these measured, you could. It takes a little bit of time and patience, right? But you could, and you'll notice I actually have a little mark on the gear here. So what you can do is you can, mark it where it is, and then mark this gear where it is, and turn the input at least one time. And then if the output lines right up, then when you count, then you have 1 to something. But remember in the other example, I said you could have something like 3 to 5, which means if you turned this big gear one time and the little gear did not line up with the line, you'd have to keep turning and count the number here. So in that example, you'd have to turn this one 3 times, and then this one would turn 5 times, okay? But in this case, it's 1 to 5. All right, 1 to 5. And that's how you get the ratios of gears. But I want you to really get the basics of just figuring out that if I'm turning one gear, and if it's a small gear, I'm going to obviously have to turn it a lot more to get a big gear to turn, okay? And so I want you to think about the circumference. Every time that gear travels around, it's moving a distance on that outside. In order for it to move that distance on the outside, it's turning another circumference or distance. So if it's a small distance, you're going to have to go a lot more small distances to get that one big distance. And if it's a big distance to a small one, you're going to only have to turn that one distance one time, and the small distance you're going to have to turn a lot of times. All right, so think about input and output. If you have any questions, go ahead and leave them in the comments below. Make sure to like, subscribe, and click that little bell for notifications.